Okay. So, quick little review. Forces are vector, which means that they have to have three things. One of them is units. What are the other two things? It's a vector. How did Vector commit his crimes?
Oh, never mind.
Magnitude and something else.
And
Direction.
direction. Good.
Yeah, I knew it.
Stole the moon.
Chronogon. Magnitude, which magnitude is really just a size or a number, right?
Direction and magnitude.
Okay. We also talked about net force is going to be the combination of all the forces acting on an object. And we call the combination of those the resultant. If forces are in the same direction, do we add them or subtract them? If I have two forces both going to the right, Layla? Add them. Adding vectors. If they're going in opposite directions, what do we do? Echo?
Subtract.
Perfect. Subtracting vectors. So for example, 20 newtons to the right plus 22 newtons to the right, same direction, we add them to get our 42. Here they're pushing in opposite directions and it looks equal. We are looking at a net force or resultant of 0.
No.
No?
100 and 150.
Oh, shoot.
He's trouble.
I was trying not to have to scoot down. Dang it. Oh, close. Okay.
Okay,
Now,
you're making noise. You're making-
These arrows I actually should have made
I kind of
where this arrow is bigger because that's the stronger force, so that vector should have been bigger. So it's not perfectly accurate, but opposite directions, we subtract them, so we get what?
50 to the left.
Good, 50 newtons to the left. Now they're equal, 45 newtons left, 45 newtons right, opposite directions, subtract them, still 0.
So,
Good.
big
All right.
channel.
So that's all kind of review. This is something that's really, really helpful because we learned yesterday that the Newton comes from the mass unit times the acceleration unit. Well, those units are not random. They are set and they are always very specific. So the mass unit is always going to be the kilogram, not some version of the gram, not milligram, gram, centigram. It's always exactly going to be the kilogram. So there's no question on all of these problems, mass is always kilogram, right? Same thing with acceleration. The units are always the meter per second squared. So if it's the meter per second squared, there's no question about it. Like, you always know what your acceleration unit's going to be. And then the same thing for force. The units are always the Newton. And I did look it up. Sir Isaac Newton did not name the Newton. It was just named after him years later. Which is what I thought, but I wasn't 100% yesterday. Okay, so our equation for Newton's second law is force equals mass times acceleration. So F equals M. You can do the times A, you can just do the MA, you can do the M dot A, however you're comfortable putting that down as multiplication. So we just said the unit of force is going to be the capital N Newton. For all of these, mass is always the kilogram, and acceleration is always the meter per second squared. Non-negotiable, no debate, never anything other than those three units, which makes this probably the most simple thing that we do when we're talking math and equations, because there's no question. You don't have to read the problem and pick out the units for mass. It's always the kilogram. Same thing with the Newton. You don't have to decipher it or decode it or try to figure it out from the problem. Always the Newton and always the meter per second squared. So absolutely no reason to ever get any of these units wrong either, because they're always there for you. Okay, so now that you have that filled in, you can look back at that if you're doing a problem and you get stuck on the units. You have them kind of identified already. So I don't care how you round, this is just for practice. So if you need a calculator, go ahead and grab one real quick. Connor, here's the papers from when you were active. Good work.
EL 24S or 3S. I got the EL 24 3S.
So we're gonna go about these the same way that we have all year. We're gonna underline everything that we know, and we are going to circle what the problem is asking us to solve for, right? So a baseball with a mass of 0.8 kilograms is given an acceleration of 20 meters per second. How much force was applied to the ball? Give me something to underline, Caden. What is a piece of information given? Good. So what I do up here, I would like you guys to do on your paper as well. These are going to be your examples. Brooklyn, give me something else to underline. Good. What are we solving for, Billy? Okay, so force becomes my question mark. My mass is 0.8 and my acceleration is 20. So I'm using force, or I'm solving for force, so it's just the standard equation of F equals ma. So my mass is 0.8, my acceleration is 20, and when you simplify that, ready?
16
Good, and what are the units gonna be?
kilograms per second.
It is, but how do we shorten that? Because we don't want to have to do that every time. What a pain. Layla? Good. Capital N, the Newton. You're right. You put them together like we've been doing all year. And when they saw that jumbled mess, that's why it got changed to the Newton. And that's why it has to specifically be the kilogram and the meter per second squared. Because you change the size of it. Like if you would have a gram versus a kilogram, that throws the proportions off, or the scaling off. So that's why it has to stay kilogram and has to stay the meter per second squared, because those are what give us the Newton. Good. So again, what I have on the white paper, or on the board, you're putting on your white paper as well. Okay, a golf ball is hit with a force of 15 newtons, and it travels with an acceleration of 25 meters per second squared. What is the mass of the golf ball? So, Dane, give me something to underline.
15.
Okay. Veronica, something to underline. Good. And what are we solving for here, Kendall? Very good. That's going to be my great unknown, my question mark here. And so I fill in my force of 15, my acceleration of 25, and now I need to set this up for mass. So I go to my triangle, I cover it up, and I do force divided by acceleration, correct? Look right? I've already made one mistake today, so make sure you're checking me. Good. Oops. So mass equals our force of 15. Hold on. I got messy. Mass equals 15 over acceleration of 25 for 80.
0.6 kilograms.
Good. Any questions there? Mass, and all you have to do is if you forget, look at the front. You've already identified what the mass units are. It's always going to be the kilogram. Okay. go to number 5. Brookston, give me something to underline.
1,500 newtons.
Good, so a force of 1,500 newtons is applied to a 1,000 kilogram car. What is the acceleration? Garrett, give me something to underline.
1,000 kilograms.
Good. Connor Stockdale, give me, what are we solving for?
Acceleration.
That's what we circle. That becomes my question mark. Okay, so I start filling in my force of 1,500, my mass of 1,000, acceleration is what I'm setting it up for. So, let me do a quick triangle here. Since mine's off the screen. So we're gonna have F, M, A, and this is divide, this is multiply. So setting it up for acceleration, so I cover up acceleration. What am I gonna rearrange this to? Acceleration equals what? Kayla? Good. F over M. So now I just plug in. My force of 1,500, my mass of 1,000, and what do we get? Garrett?
1.5 meters per second squared.
Very nice. Good? Okay, what you're gonna do is I want you to finish the last 2 on your own, bring it up and show me, and then you can have the assignment paper. The purple paper that you're gonna get from me is going to be an assignment. You will turn it into the tray when you are done. Hold on, let me get my stuff out of the way here.
Just marking ahead. Or just trying to teach.
Way to be paying attention. Sir, can you touch me? We don't sit here anymore.
That's I used to do.
My ass.